Hello, Michael here. In this video, we're going to learn about literal equations. We'll focus on simple one-step equations. We'll do harder one-step equations and do two-step equations in other videos. We'll work through 8 examples together, but before we do those 8, before we do each of those, I'll work through a similar example with numbers so we can focus on what we need to do and so we can review. And then I will give you 16 exercises you can work on your own. Now, literal equations, what are they? Things you've already seen, like this. A equals LW. This is the formula for the area of a rectangle. It's a literal equation when it's got mostly letters in it, or all letters, whereas the thing on the bottom is not a literal equation. You had to put some numbers in to figure out the area. Here's another one. The formula for the perimeter of a rectangle. You've probably already seen this one too. So that's a literal equation. But if it was like this at the bottom, we'd just be solving for L, and that's not a literal equation. This one also, the formula for the volume of a cylinder. Now, why do we need this? What's the point? Well, for working with cylinders and pistons for one reason. Of course, some people don't care about this, but that's not the point. The point is to see, watch this example, see how it works, and see how it applies to things you are interested in. Now this one here, it's a cylinder, and so that's the volume. We're going to learn how to do things like solving for one of the variables, so we'd solve for h. And then when you get to calculus, you can do fancy things like this. Yeah, you don't understand this now, don't worry about it, big deal. This is just to show you where you can go. So this just says the height of the cylinder is going to change an amount equal to a change in the volume of the cylinder divided by pi r squared. That's when the radius stays constant. Okay, and it comes up, literal equations, they come up in diving. So with increasing pressure on you, your blood tissue will dissolve more nitrogen, and you got to worry about that when you come back up. It's no big deal having the nitrogen in you. Big deal. It doesn't bother you. It's just when you come up, you need to be careful about it. And this equation is relevant to that. This is a literal equation. Now, what does this mean? This means when you're in the water, like my drawing, isn't that great? I'm such a great artist. But when you're in the water, underwater there, the atmosphere, the P0 there, is pushing down on the water, and then the water is pushing down on you. So you've got to hold up water and the atmosphere. So, you know, whenever you're walking around, you've got a bunch of air above your head. It's pushing you down, and you're holding it up. So in this case, it's like you're lying there, and someone lies on top of you, and that's like the water, and someone lies on top of that person, and that's like the air. So you got to hold up the water and the air. And if you go down deeper, there's more water above you, so there's more weight, there's more pressure on you. If you go down even farther, there's even more pressure. So you have the pressure of the atmosphere plus the pressure of the water, which depends on the height h. So the atmosphere is always kind of about the same, and it's pressing on the water. And the more water above you, the more the height of the water above you, the more you're adding to the pressure of the atmosphere. So, you know, again, with increasing pressure on you, your blood and tissue will dissolve more nitrogen. Then you got to be careful going back to the surface, because if you don't do it right, you could have major pains or internal organ problems, or you could even die. That's rare, but it does happen. So be careful going back up to the surface and dig into things. Know your literal equations so you can help yourself. Hopefully you're interested enough in your life, in your health, and you care enough about yourself to look into this stuff. Look at cause-effect relationships. Okay, yeah, maybe you're not interested in diving. I'm never going to dive, but I still think this is interesting. But you need to take this and dig into things that you are interested in and that you do. Okay, now one point I want to make, the diving thing, you're not going to worry about that if you're in the water a little bit, like a 12-foot pool or whatever. It's not going to matter. It's only when you get down below 100 feet, maybe 60 feet, but when you get down deep for a while, and then you come up, then you have to worry about it. So, literal equations come up like with your dog collar. If you put a collar on your dog and you shock it, well, how much current it feels depends on the voltage of the battery and the muscle in the area. You know, you can look up on YouTube, and there's some people who have put a dog collar on, and you can see how they like it. The more current, the more it bothers you. Too much current can be really bad. Or, you know, you put sun lotion on, well, look up that. All this stuff you can do your own research on. You should care enough. You got the internet, you can look it up, you can see what chemicals break down in sun lotion, how the sun does that, how much your skin will absorb. So you get a bunch of gunk absorbed in your body if you put on bad sun lotion. You want to try to get natural stuff, not a lot of the commercial stuff. Okay, so those are some reasons why we should look at literal equations. A lot of stuff comes up in life. It's the things I mentioned and a heck of a lot more. Now, what do literal equations depend on? What do you need to know? You need to know arithmetic. For example, division is the opposite of multiplication, and subtraction is the opposite of addition. So if we do 10 plus 5 minus 5, 10 plus 5 minus 5, you can write that down and stop the video and think about it. You get 10. Adding 5 and then taking away 5, they undo each other. Okay? You need to know about one-step equations with numbers. Maybe two-step equations with numbers would be good also. And have an abstract idea of how equations work and what a variable is. If you have a problem understanding some of this, then it's probably just a background issue. Get better at your arithmetic, do some more one-step equations with numbers, do some two-step equations with numbers, and you'll be okay. So here are the first 4 we're going to work on. We can do these 4, and then you can stop the video, take a break if you need to, and we'll do 4 more. But before we do each of those, I'm going to do these 4, so we can review what to do with numbers so you can feel more comfortable with this. Okay, the second set of 4 is right here. So, you know, if you want, you could stop the video, try to work through these on your own and look at the explanations, see if you get them right. But we're going to go through them. But before I do each of those, I'm going to do these so you can remember how to do those with numbers. But these 4 in black on the right are the same thing as what we've already done if you look back at the 1 through 4, but we have different variables different than x. Okay, example number 1. So let's start into it. X plus 3 equals 5. So we're getting a number, x, adding 3 to it, and ending up with 5. Remember, addition and subtraction undo each other, so we take 3 away from each side. If you take a 3 away from the left, you have an x only. And then on the right, we'd have 5 minus 3. So it's like a balance scale. Whatever we do to one side, we have to do to the other. So we take away 3 from one, so we take away 3 from the other side of the balance at the same time, and we end up with 2. And I talk about that in a video on two-step equations, about the balance. So if you need to learn that or review it, it's in that video. So here's the same thing, but this is a literal equation. See the comparison? X plus a equals 5, x plus 3 equals 5. Since we have 2 letters, we have to say solve for x, because we don't know which one to solve for, unless someone says, or we know from a context of what we're doing. X plus 3 equals 5, well, clearly we solve for x, obviously. But x plus a equals 5, it's like, which one do we get? So we're solving for x. Now, first of all, remember what we did was take away 3. We took 3 away from each side. So we take a away from each side. X plus a, we undo that by taking away a, minus a. And remember we got, for the other one, x is 5 minus 3. Okay, so what do we get here? 5 minus a. X is 5 minus some number. just like x is 5 minus 3. All right, cool. Let's go on to number 2. So we have 2x equals 50. All right, now how do we solve this one? We're multiplying x by a number. We undo that by dividing by 2. Undo multiply by 2 by divide by 2. And what do we get? X is 50 over 2. 50 divided by 2, which is 25. 2 times 25 is 50. So now we'll do the same thing, but with the literal equation. X times y is 50. Some number times another is 50. And we're going to solve for x. Okay, look at the two and compare them. So 2x equals 50. What do? We divide it by 2. And that'll get us the x alone. We have x times y. We undo that by dividing by y. Okay, but we have to do that to both sides because it's like an equation is like a balance. And remember, on the other one with numbers, we got 50 divided by 2. So we do the same thing. We get 50 divided by y. X would be 50 divided by some number. So look at the two and compare them. And we've got the y in place of the 2. All right, next example. X minus 3 equals 5. How would we solve this? We'd add 3 to each side. We do plus 3. And we end up with x is 5 plus 3, which of course is 8. All right, 8 minus 3 is 5. Here's the literal version of that. X minus a equals 5. Now we're going to solve for x, not for a. So let's look at these side by side and compare. What do we do first with the number one? We added 3. So we do the same thing with the literal one. We add a. We undo subtract a number by adding that same number. If we do 10 minus 3 plus 3, we end up with 10. 10 minus 3 plus 3. If you think about that, write it down, whatever, you end up with 10. You get back to the same thing. So any number minus 3 plus 3 is back to that number. So we added a. Okay, with the number we would have got 5 plus 3. So with this one we get 5 plus a. Simple as that. Okay, next one. X over 2 equals 50. We have a number, we take half of it, and we get 50. So what do we divide by 2 to get 50? Well, clearly 100. Now let's work through this. We'll see we get that. We undo divide by 2 by multiplying by 2. Multiply both sides by 2, and we get 100. All right? So what about this one, a literal equation? All right, let's compare them side by side. We're going to solve for x. So remember with the number one, we undid divide by 2 by multiplying by 2. So same basic idea. We undo the division by multiplying. We multiply by y. And that gets rid of the dividing by y. What do we end up with? X is 50y. Just like we got x is 50 times 2. 50 times y, 50 times 2. You know, we're just putting a y in place of the 2. So this could be for any number. X is 50 times any number. All right, that was the first 4. If you need to replay and look at those again, go for it, or stop and take a break. That's cool. We're going to work on these 4 now. Notice 5 through 8, the literal equations are all letters now, no numbers at all. And we're doing different variables besides x. So on to number 5. We're just going to go straight into this since we've done some equations with numbers like this already. So y plus a equals b. So let's compare these side by side. If we're solving for y, this would be like y plus 3 is 5. So what do we do first? We would have subtracted 3, right? Y plus 3, we undo that by subtracting 3. So, same thing, we subtract a. Subtract the number that we're adding to y. So remember, with the number, we get y is 5 minus 3. So we get the same kind of thing. We get y is b minus a. We took away an a from each side. Now what do we have on the right side of the equal sign? B minus a. Okay, now I'm going to show you this so you're familiar with it both ways. It's the same thing we just did, but the y plus a is on the right instead of the left. And you can look back and see. Some people are a little uncomfortable with this. You just got to not worry about it. We do the same thing. It's okay. So first thing we do is take away the a. We have y plus a. We don't want that a there, so we take it away. We subtract it. So we get y is b minus a, just like we did before. You can rewind and check it. We could say b minus a equals y, or y equals b minus a. They're equal to each other, so it doesn't matter which side is on which side. Okay, next one. This time we're going to solve for k. We need to get used to solving for different letters, because like we saw earlier, with the pressure and everything, in the volume and area, we use all kinds of different letters and not just x. So yk equals r. How do we do that? Well, it's like 2k equals 50. And how do we solve that? We divide by 2. How do you undo 2 times k? You undo that by dividing by 2. Okay, so we divide by y. Y is multiplied by k, so we divide by y to get rid of the y. And remember, on the number equation, we get 50 divided by 2. So on the literal equation, we get r divided by y. You have whatever's left. If you put your hand over the left side of the equal sign and look at the right side of the equal sign, it just says r over y. And so that's what k is. Simple as that. You know, the 50 is where the r is, and the 2 is where the y is, so you can compare them side by side to be more comfortable with it. All right, we're going to do the same thing, but it's switched around. It's on the right side, so what? We still solve for k by dividing by y. So we divide, and we get the same thing. K is r divided by y. That'd be our new formula for something we're going to do. Okay, number 7. Solve for b. b minus a equals h. One number minus another equals a third. So we're going to compare it to this one. So what would we do? b minus 3 is 5. To get the b alone, we add 3 to both sides. So just like we did there, we add a to both sides to get rid of the a, because we want to get the b all alone, get everything else away from it. And what would we have gotten when we added the 3? Well, 5 plus 3. b is 5 plus 3. It's 8. 8 minus 3 is 5. So just like that, following that pattern, we get h plus a. b equals h plus a. All right? Let's do this with them switched out. Again, same thing. We want to get the b alone. We're solving for b, so we add a to each side. And what do we get? b is alone on the right, and h plus a is on the left. But since it's a balance, it's a scale, the two things are equal, we can say b equals h plus a. Okay, just like we got before. You can rewind it and check it out. b equals h plus a, it's what we got. Number 8, last one. Okay, solve for q. Q divided by y is t. One number divided by a second is equal to a third number t. So let's compare it to this one. So we have q over 2 equals 50. Half of something is 50. We multiply by 2 to solve that. Remember, divide by 2 is undone by multiplying by 2. So we do the same kind of thing. We multiply by y. The divide by y is undone by multiplying by y. And what do we get? Q is ty. Just like q is 50 times 2. You put the t in place of the 50 and the y in place of the 2, and you'd have ty. Okay, let's check this out. Same exact thing, but switched around. Maybe you don't need to do this, but when we're solving for the variable on the right, some people have trouble with it, but we just need to learn it's okay. So what we could do is just solve by y, multiply by y. Instead of having a q divided by y, remember, to undo that, we have to multiply by y. And then we get q equals yt, just like before. So practice some one-step literal equations on your own. We'll give you some. Got 16 coming up. You can go through the video and watch it again and practice them on your own. You can do the ones, the 8 that we've already done, then watch the video again, see if you get them right. Maybe that'll help. And then we're going to go on to some harder ones in other videos. So you'll be doing something like these. These are still one step, but a little harder. Then we'll go on to two-step literal equations, like these, where you're solving for L, you're solving for H, you got more stuff to do. And then you can go on to harder ones, like these. Yeah, it's a lot, don't worry about it, you'll get to it. We'll get to there. Here are 16 you can do. Some are number equations to just help you remember that and review it, like number 1 or number 3. And then some are all letters, like 14. And I'll tell you which variable to solve for. Like in 14, you want to get the t alone. The d and the r have to be on one side of the equal sign and the t on its own on the other. Now on the next slide, I'm going to give you the answers. I'm going to go over there, so if you want to stop this and work these out, do that. Here are the answers. You can check your work. Hopefully you got them all right. Now let's go back and talk about the diving in a little more detail, because this is a good example for how you should understand things. You know, whether you want to know more about sun lotion breaking down and putting toxins in your skin, you know, so you can make sure you get natural stuff and avoid the bad stuff, and you can find out about it on your own. Just because someone says something doesn't mean it's true. We can't just listen to everything everybody says. Like, just doing that is what kept people from learning how to make a plane that turned. The Wright brothers were the first ones to invent a plane that they could turn because they looked at things on their own. Everyone else was using a formula that was wrong, a formula developed by some world authority, but the Wright brothers figured things out on their own. You know, and hopefully with this thing we've talked about with diving, you see how it can affect your life. Hopefully you care enough about yourself to look into this. You can do it. Do the research. Now remember, with increasing pressure on you, your blood and tissue will dissolve more nitrogen. This is a matter of chemistry and physics. You'll have to study some stuff to get to know this in the first place. And you can look this up on the internet and look at YouTube videos about pressure and volume and temperature and gases. Okay, the thing we want to focus on now, though, is this law about pressure that we talked about earlier. Remember, you got the atmosphere pushing down on you, and then when you're in the water, you got water pushing on you as well. So if you're outside, you know the atmosphere pushes on you because you can feel it when you're moving, like, or when the wind blows. Wind blows and pushes trees. So the wind is easy to run through, but there is something there. There's stuff. Or if you're driving along at 50 or 40 or 60 and you put your hand out the window, you can feel a hard push on your hand. It can be hard to hold your hand there. There's stuff that is out there. So all this stuff is resting on your head. You got a big column of air that you're holding up. And that's the P0. You know, and it pushes down on a pool of water or a lake or the ocean. So when you're diving in the ocean, there's a bunch of water or a bunch of air pushing down on the surface of the ocean. And then you got water pushing down on you. So that awesome stick figure there, that could be you or some person. And you got the PGH. H is the height of water. The other stuff, don't worry about it. When you get to know this stuff more, you'll understand it. We're just getting a common sense view of it, knowing the basic cause-effect relationships. So the H is the height of the water above you. You got water pushing on you and air pushing on you. Or it's like water resting on you and air resting on you. Okay, like I talked about earlier, if you're lying on the ground and someone lies on top of you, that's like the water. Someone else lies on top of them, that's like the air. And they're both pushing down on you, putting more pressure on you, making it harder for you to breathe, making you feel a little uncomfortable. Okay? It's harder to breathe. That's why oxygen tanks for diving have to be pressurized so you can actually breathe it. Now, if you go down deeper in the water, there's more pressure on you. That'd be like a person that weighs a lot more on top of you and the same person that represented the air on top of that person. So you'd be squished even more. You know, water's heavy. You can try putting a couple of milk jugs of water on your back and see how it feels. And then imagine that multiplied by like 10 or 100 or something. And if you go deeper, there's even more water above you. So there's more pressure on you. So that's what this equation means. PO is the atmosphere pushing down. And the PGH thing, just remember H stands for height, and that's the height of the water above you. Now, when people combine that with Henry's law, which relates pressure to concentration of something, you can look that up. You know, you got Wikipedia, YouTube videos, the internet, so you can learn about how that works. I'm not going to get into it. You got Dalton's law involved in all this. Again, P for pressure. That's what literal equations help us do. It's like, hey, we got the same letter, like the same concept. It's pressure. So is this stuff related? How do we put it together? So literal equations are very helpful. And then Boyle's law comes into play as well. PV equals K. Pressure times volume is a constant. Look it up. Internet, YouTube, you can learn more. But we put all this stuff together, and we find that with increasing pressure on you, as you go down further, remember, this really starts to take effect, you know, below 60 or 100 feet. When you go deep, your blood and tissue will dissolve more nitrogen, and that's okay. No big deal. It doesn't bother you. That's fine. But if you go to the surface too fast, the pressure on you will change too fast. Then the nitrogen will come out of your blood and tissue in bubbles. And this is where there could be trouble. If it comes out too much, too fast, that could give you muscle pain, make you dizzy, cause numbness, weakness, or even death. So putting all those 4 formulas together and more, this is what we get. Of course, the formulas didn't teach us this. Reality did. When people came out of the water for the first time and had pains, or some of them died, then we understood it. We did research and figured out these formulas were relevant. So now we have diving tables. So you can see exactly how long you can stay underwater at a certain depth and how fast you need to come up. We've got that calculated based on these formulas and more. We couldn't have that without the literal equations. Very important. So you want to apply this idea to other areas that you're interested in. Okay, yeah, maybe you're never going to dive. I'm not. But if you understand this, you have a model for how to think about other things, and that's very important. When are you ever going to use the diving thing? Maybe never. Yeah, cool. When are you going to use the thinking? Hopefully you care enough about your life to do so. Thank you very much for watching. I hope you enjoyed this, and I hope it was very informative. Hope you have a good day. Bye.